I want you to imagine a specific moment. You're sitting in a room, maybe a high-stakes meeting, and someone turns to you and asks a question you weren't expecting, a hard question. Before you answer, there's this silence. It's a split-second pause. Inside your head, you're auditing yourself. You're asking, do I actually know this? Am I about to bluff? How confident am I really? That pause.
Yeah.
That is the mechanism of intelligence.
It's the difference between a reflex and a reason. And for the history of AI so far, well, we haven't had that pause. We've just had hallucinations.
Yeah.
Today, that starts to change.
Welcome back to the deep dive. I'm glad you're here. We have a stack of sources today that I think point to a fundamental shift in how these systems operate.
Yeah.
We're moving from the era of the black box, where the AI just spits out an answer and we hope it's right, to a system that essentially checks its own math. We're looking at a new framework for AI metacognition.
Metacognition. It sounds so academic, but it's really just thinking about thinking. It's the AI looking in the mirror.
Exactly. And then we're going to take that concept of modeling the self and apply it to the physical world. We're looking at how AI is modeling the Earth's atmosphere.
Oh, yeah.
NVIDIA has entered the weather wars, and the implications for who owns the forecast are, well, they're complicated.
It is wild stuff. And to keep the energy up, we also have to talk about vibe coding. Apparently, resumes are dead, syntax is dead, and we're just hiring people based on how well they can vibe with an LLM. Plus, some big hardware shifts from Microsoft.
So here's the roadmap for our conversation. First, metacognition, the new sensors that let an AI reflect on its own uncertainty. Second, the toolkit, updates from Claude, Microsoft, and this rise of the vibe coder. And finally, Earth-2, the battle to simulate the climate. Let's unpack this.
Let's get into it.
I want to start with this paper on metacognition and the next wave of AI evolution. The researchers here have dropped a framework that I think is really important to understand, but I want to be precise with our language. When we say the AI is thinking about its thinking, we aren't talking about consciousness. We aren't talking about a soul or a ghost in the machine.
No, absolutely not. We have to be so careful not to anthropomorphize. We are not near Skynet. This is engineering, not philosophy.
Right. It's a metacognitive state vector.
Which, again, sounds like Star Trek technobabble, but it's actually pretty practical. Think about how large language models, LLMs, usually work. You give a prompt, it predicts the next word, it's a probability engine, it's incredibly fast.
Right.
In psychology, specifically in the work of Daniel Kahneman, we'd call that System 1 thinking.
Fast, intuitive, reactive. If I ask you, what is 2 plus 2? You don't calculate it. The number 4 just appears in your head. That's System 1.
Exactly. But if I ask you, what is 17 multiplied by 24? You stop. The answer doesn't just pop up. You have to engage a different gear. You have to grind through the logic.
That's System 2.
That's System 2. It's slow, deliberate reasoning. And up until now, AI has been kind of stuck in System 1. It just blazes through, confident even when it's completely wrong.
Yeah.
This new framework gives the AI a dashboard to see when it needs to pump the brakes and switch gears.
I love that distinction, the ability to switch gears. So let's look at the dashboard. This framework introduces 5 specific dimension sensors, essentially, that the AI tracks internally. The first one is the most obvious, confidence. How sure am I?
But it's not just a binary yes or no, it's a gradient. The system tracks the probability variance of its own tokens. If the confidence score drops below a certain threshold, say, it's only 60% sure of the next logical step, the system flags it.
So it basically says, wait, I'm entering low probability territory here. I need to verify this before I speak.
Precisely.
The second sensor is conflict detection. Am I contradicting myself? This is huge because we've all seen an AI write an essay where the first paragraph claims one thing.
And the conclusion claims the complete opposite, yeah. It's like the AI is listening to its own output stream and comparing it against what it just said. It's checking for logical dissonance. If paragraph 1 says the project is under budget, and paragraph 3 says costs have overrun, the conflict sensor spikes.
In a standard model, it would just keep going, just keep hallucinating.
Right. In this model, that spike forces a correction.
Then there's experience matching. Have I seen this before?
This grounds the reasoning. It checks the current query against clusters of its training data. If the problem is highly novel, something totally outside its distribution, it recognizes that it's guessing, and it lowers its own confidence score.
It's the ability to admit ignorance, which is surprisingly difficult to engineer.
It really is.
The fourth one is interesting to me. Emotional awareness. Is this content loaded?
This acts as a safety valve. It's not feeling emotion, obviously, but it is detecting the stakes of the language. If a user is aggressive or the topic is politically charged or sensitive, like a medical crisis, the AI detects that weight.
It signals that this isn't just a casual chat. It requires a higher degree of precision and care.
And that ties into the fifth one, problem importance. Is this worth slowing down for?
That's the efficiency key.
Exactly. You don't need deep, slow, expensive reasoning to write a haiku about a cat. That's a waste of compute. But you do need it if you're analyzing a legal contract. This sensor tells the AI when to spend the resources.
So when you combine these, confidence, conflict, experience, emotion, importance, you get the state vector. And the result is that instead of a black box giving you an answer because I said so, you get explainable steps.
Right. You get an output that looks something like, I chose this strategy because I was 92% confident, I detected no internal conflict, and the problem importance triggered a deeper review.
You know, I have to admit something here. I still struggle with prompt drift. I'll be working with an AI on a long thread, maybe for coding or writing, and after 10 minutes, it starts getting confused. Or honestly, I get confused about what I originally asked.
Yeah, that happens.
The idea that the AI could stop and say, hey, I'm feeling low confidence here, or I think we're contradicting the original goal, that is such a relief.
It changes the dynamic completely. It removes the burden of you being the only adult in the room.
Yeah.
You're just prompting. You're collaborating with a system that has a sense of its own limitations.
But let me ask you this. If the AI tells us why it's confident, does that actually fix the hallucination problem, or does it just give us a better excuse?
That's the big question. And the short answer is, it doesn't fix it perfectly. The AI can still be confident and wrong, but it makes the error transparent. It moves us from silent failure to auditable failure.
Transparency over perfection. I can work with that. Okay, let's shift gears. We've looked at the internal wiring, the mind of the machine. Now let's look at the tools on our desk.
The landscape is moving so fast. We've got updates from the big players and some really interesting new concepts in how we actually work.
Let's start with Claude. Anthropic has been busy. They've opened up Claude for Excel to pro users now.
Finally, and this isn't just about reading a spreadsheet. The big deal here is memory and integrity.
Context rot.
Exactly. Historically, you'd feed a CSV to an AI, ask it to fix a column, and it hallucinates the rest of the sheet, or just deletes rows. This update allows it to handle multi-sheet workbooks, and, crucially, it doesn't overwrite your data.
It edits in place.
Yes, it keeps the context of the whole workbook.
Yeah.
Just the difference between a toy and a real tool. And they've also launched interactive apps. You can run Slack, Figma, and Canva directly inside the Claude chat.
It's becoming an operating system. You aren't just chatting, you're executing.
Speaking of execution, Microsoft is hardening the infrastructure. They just unveiled the Maya 200 chip. It's rolling out in U.S. data centers to power Copilot.
30% faster, same cost.
Yeah.
So why does that matter to the listener?
It matters because of the token tax. Every time you ask a deeper question, it costs time. Faster chips mean the AI feels less like a loading bar and more like a real conversation. It's the invisible plumbing that makes everything else possible.
And on the creative side,
Crea AI, they've launched real-time photo editing. You aren't waiting for a render. You tweak the prompt, the image changes instantly, it's fluid, and Synthesia just raised $200 million.
wow.
They're building agents that interact with training videos. Imagine a corporate training video that answers your questions instead of just lecturing you. That's the vision.
But the story that really caught my eye in this stack, vibe coding.
I knew you were going to bring this up.
I mean, come on. There's a startup called Anything, and they are hiring. But the job posting is unique. No resume, no GitHub repo. You just reply to the post.
They're looking for vibe coders. The whole premise is fascinating. They argue that with the current state of LLMs, you don't really need to know Python or C++ syntax anymore.
Right.
You need to know how to talk to the AI to get it to write the code.
It suggests that coding is shifting substrates. It's moving from syntax, knowing where to put the semicolon, to pure intent. It's about being able to articulate a vision so clearly that the machine can build it.
It's the democratization of software creation. But it's also probably a little terrifying for the purists.
So here's the question. With vibe coding and tools like Verdant, which is another new one that coordinates multiple AI agents to code while you step away, are we seeing the end of the developer, or is this just an evolution?
I think we're seeing the evolution of the architect. The person who lays the bricks, the syntax, is being replaced by the machine. But the person who designs the cathedral, who understands the flow and the purpose, that role is more important than ever.
From bricklayer to conductor.
Exactly. You aren't typing code. You are orchestrating intelligence.
Okay, we've looked at the inner mind of the AI metacognition. We've looked at the tools, chips, and vibe coding. Now, I want to zoom out, way out, to the atmosphere of the planet itself.
This is one of those stories that feels like it belongs in the future. But it happened last week at the American Meteorological Society meeting.
NVIDIA, a chip company, announced something called Earth-2.
Earth-2. It sounds like a backup planet, doesn't it? It's
Yeah.
a fully open-source suite of AI weather models.
So how does a graphics card company predict the weather? Usually we do this with physics.
Right. Traditional forecasting is physics-based. We use these massive supercomputers to solve fluid dynamics equations. It's incredibly accurate, but it's computationally heavy and it is slow. NVIDIA is taking a different approach. They're using AI.
They're ingesting public Earth observation data, satellites, weather balloons, all of it.
Billions of chaotic data points. And this is the moment of wonder for me. Think about the atmosphere. It's messy. It's noisy. There are gaps in the data. The AI takes this chaotic input, clouds moving, pressure dropping, and it smooths it. It creates a continuous estimate of the atmospheric state.
It's like taking a blurry, pixelated image and using AI to upscale it to 4K resolution instantly.
That's a perfect analogy. And because it's AI, it is fast. NVIDIA claims Earth-2 now outperforms those traditional physics-based models for short-term precipitation forecasting.
That's a massive claim.
It is.
And the context here is vital. The newsletter mentions that federal funding for traditional forecasting is, well, it's drying up.
It is. The public systems, the ones that farmers, wildfire response teams, and flight planners all rely on, they're under pressure. The satellites are aging.
And into that void steps NVIDIA, along with Google, Microsoft, and Huawei. They are all entering these weather wars.
They see the value gap. Climate risk is the single biggest variable for the global economy. If you can predict the storm better than the government, you hold the keys to a lot of value.
It raises a pretty serious question about access, though. If federal funding is drying up and the tech giants are taking over the weather models, what happens to public access to that data?
That is the big question. Does climate safety become a paid premium service? Does a hedge fund get the NVIDIA forecast that says it will rain at 2:04 p.m. while the public gets a generic chance of showers? It turns weather into an information asymmetry.
It's a sobering thought.
It is. But on the flip side, the technology itself is incredible. The ability to model the Earth with this level of fidelity could save countless lives in disaster zones. It's just a matter of who holds the controls.
So let's try to pull this all together. What's the thread connecting these segments? We started with the micro giving AI an internal sensor system to check its own confidence.
Yeah.
We moved to the macro Earth-2, using AI to sensor the entire planet.
I think the theme is precision and reliability. We're moving past the guesswork phase of generative AI. We're moving past the novelty phase. Now we're asking, can it check its own math? Can it reliably code an app? Can it predict a hurricane better than a physics engine?
We're demanding that the systems double-check themselves.
Exactly. Metacognition builds trust internally. Earth-2 builds trust externally. We're trying to build a digital substrate that actually maps to reality.
I want to leave you with a thought to mull over. We talked about the AI checking its own confusion. We talked about it modeling the chaotic atmosphere better than physics equations. If AI can detect its own blind spots, and if it can understand the physical world better than we can, at what point do we stop double-checking the AI?
And start having the AI double-check us.
Exactly. Would you trust a weather forecast from NVIDIA over the National Weather Service? It's not a hypothetical anymore.
I'd check both. For now.
Yeah.
But I know which one is learning faster.
Let us know what you think. Until next time.
See them?